Now we're going to talk about factoring. Okay, so the first method for factoring is the greatest common factor. Let's start off with a simple example, 4x plus 2. And if I wanted to factor out the greatest common factor, each of these terms is divisible by a 2. 4 divided by 2 is 2, 2 divided by 2 is a 1. So here I'm going to pull the 2 out front, and 4x divided by 2 leaves you a 2x. The 2 divided by 2 leaves you a 1. Okay, if you wanted to check your answer, you would multiply that 2 back in, distribute it, and you would see it's 4x plus 2. Easy example. We have a special rule that's called the difference of perfect squares. Difference of perfect squares. And that uses the formula a plus b times a minus b is equal to, well, let's multiply these out using the FOIL method. The first times first, you get a squared. Outer times outer, you get a times negative b, so we'll call that negative ab. Inner times inner, you get a times b, but the commutative rules say that we can rearrange any way we want, so we're going to write it as ab, right in alphabetical order, so that we can compare it to our previous term. And then our last times last, we have b times negative b, we get a negative b squared. Okay, but then you see these two inside terms, negative ab plus ab. They cancel out. And so you get a squared minus b squared. Remember, this negative goes away because it was part of the ab. It canceled with the positive ab. So what that's saying is, remember, factoring is the opposite of multiplying. It's dividing it out into separate parts. And so that's saying if we have two things multiplied together that are the same term on first, last, the middle is a plus, the middle is a minus, that you get a squared minus b squared. Or if you have a squared minus b squared already, you want to factor it, you can factor it into this format. So let's take a look at an example if that's a little confusing to you. Okay, first example, 4x squared minus 1. You may look at this and say, well, how does that fit? Well, 4x squared, 4 is a perfect square, x squared is a perfect square. 4 is 2 squared. So if I wrote this as 2x and the whole thing squared, 4x squared is 2x quantity squared. And the 1? Well, 1 is 1 squared. So now you know your a is 2x and your b is 1. Basically, if you take the square root of each part, that gives you what your a and your b are. And so here I have 2x plus 1, and I have 2x minus 1. I took the square root of 4x squared, I took the square root of 1, and I put a plus and I put a minus in between. Now if I FOILed that, I would see I have the correct answer. 2x times 2x gives you your 4x. 2 times 2 is 4, x times x is x squared. Your outer times outer, 2x times negative 1, negative 2x. Inner times inner, 1 times 2x, so you get a plus 2x. Last times last, 1 times negative 1, you get a negative 1. These two, they're going to cancel out every time when you FOIL one of these. So you get 4x squared minus 1. That's what we started with, and that's perfect. That's what we should have when you factor something and you multiply it back together. You should get what you started with. Factoring is just the opposite of multiplication. It's like a division. So this was our answer. If we wanted to factor 4x squared minus 1, we took the square root of the 4x squared, made it 2x, put it in the first spot on each of them, took the square root of the 1, put it in each spot, put a plus and a minus in between, and that's what you get when you want to factor. So let's try another one. If I have 9x squared minus 16, it has to be a minus in between. This is called the difference of perfect squares because you have to have a difference, a subtraction in between the two. Otherwise, if it's an addition, it doesn't work. Okay, so take the square root of 9x squared. The square root of 9 is 3. The square root of x squared is x. We're going to put that in the first position on each of them. Take the square root of 16. The square root of 16 is 4. 4. Put a plus in, put a minus in. There you go. If I distributed this, I'm going to get 9x squared minus 16. Okay, factoring by grouping. Factoring by grouping means we're going to look for, here we have, 2x plus 2 plus 4x squared plus 4x. So here we have a string of variables, or string of terms, because this doesn't have a variable in it. And I was told to factor this by grouping. Well, I want to look for things that have common terms. Of course, 4x squared and 2, I could factor out a 2. 4x squared and 2x, I could factor out a 2x. 4x squared and 4x, I could factor out a 4x. 2x and 2, I could factor out a 2. So I'm just going to pick a way to group. And since they're already ordered, I'm going to group here, and I'm going to group here. The associative property says that we can reassociate any of these any way we like. That's why we're allowed to add parentheses the way we did. Okay, so here I have 2x plus 2. What's the greatest common factor that I would factor out? They're both divisible by 2, so I'm going to bring the 2 out front. Well, 2x divided by 2 leaves you an x. 2 divided by 2, anything divided by itself is 1. We carry the plus down. Then here, 4x squared plus 4x. Well, they both have a 4. They both have an x. This one has an extra x. So let's just pull out 4 with one x. 4x squared divided by 4x. Well, the 4's cancel out. This x takes away one of these x's, and you're left with an x inside. 4x divided by 4x, anything divided by itself is 1. And so here I have 2 times x plus 1 plus 4 times x plus 1. So I factored by grouping, but I'm not done yet. What you'll see here is I have 2 things multiplied, 2 things multiplied. I have a plus in between, but this part is actually the same as this part. So that means I can pull an x plus 1 out front. Here I had 2 times x plus 1. If I divided the x plus 1 out front, that means I'm just left with a 2 inside. So this x plus 1 came out front. Then I have a plus. Here I have 4 times x plus 1. This x plus 1 came out front already, so it was 4x times x plus 1. So when the x plus 1 comes out front, you're left with a 4x inside. And this already moved out front, and there you have x plus 1 times 2 plus 4x. But there's one more thing here. I can pull out another 2 out of here. So if I have x plus 1 times, let's pull the 2 out front. I'm just going to put a 2 because everything's multiplied. Here I have 2 divided by 2 leaves a 1. 4x divided by 2, 2x. And so here I have x plus 1 times 2 times 1 plus 2x. Let's rearrange. Any constant terms that are multipliers, usually they go out front. So we're going to move this 2 out front. Commutative property says I can do that. Then I have times x plus 1. Then I have 1 plus 2x. Usually you write your variables first, your constant terms last. So you would write 2x plus 1. And again, commutative property says I can rearrange there. And so we get 2 times x plus 1 times 2x plus 1 as our answer for factoring 2x plus 2. So this was our original 2x plus 2 plus 4x squared plus 4x. Here we are. That was our original.